All right. I don't know what happened today, class. When I added that problem, impossible to solve. I should have known because I was like, wait, I thought I picked a pretty easy problem. It was supposed to be just like your spider problem, only a little bit harder. Which I think in the previous video you've solved that. One thing, I'm going to help you with your homework. I'm going to record classes for acceleration when we're going around the circle at a constant speed, but the velocity will be constantly changing. Therefore, all right. So since I made it almost not worth your while at all to come in this morning, I'm going to look at your homework and give you some helpful hints on how to really get started on that second homework that's due a week. That's due on Tuesday. All right, so that we don't that we'll just start with centripetal force and I'll add but I am going to keep adding. I think what I am going to do, if you notice on your expert TA, let me go ahead and close this guy. If you notice on your expert TA here, assignments, class management, just take a quick look here. See how this has a 0 weight in class? In other words, I'm going to start bringing some in-class problems that kind of correspond to what I hope are the homework problem type things. Okay, that's the idea. All right, but anyway, let's go ahead and go back. Now let's go back and do. I like to view a printable assignment here. That's easier for me to read. Now, let's just kind of go through this, just so you get an idea. All right, if someone's going to jump, all right, so let's take a look at this first problem. Consider a 69 kilogram object. Calculate the magnitude of the force in newtons must exert on the ground to produce an upward acceleration of 4 times the acceleration due to gravity. Well, how would we go about doing that? You know, it's kind of like, what? What the heck are you talking about, dog? Anyway, well, look. So here we go. 69 kilograms. All right. Yeah, 69. All right, so anyway, here we go. So we've got the mass of the jumper for the high jumper. Now, again, mass 69 kilograms. All right, so we want 2 sig figs. We want an accelerate. The overall acceleration is going to be 4g, which is equal to 4 times 9.8. That's what we're after. We're after that acceleration. Okay? So we want to know how hard they're going to have to push on the ground, okay, to get to. So, but again, what we do is we look at the sum of the forces in the y direction. What do we want? We want we want 69 times 4g. This is ma. Is equal to the normal force. Now, when see, I'm so out of the loop anymore with the NBA and everything. I don't even know who the Sky Kings are anymore. You know, I kind of used to know back when Michael Jordan was one. That's been 20 years. Okay, and I know, and Steph Curry isn't really a real Sky King anyway. He's a and neither is LeBron James. Well, LeBron James can still leap. I mean, 6'9", 240, and he can still sky with the best of them. Or about 260, I think is what he goes. But anyway, but the key to this problem, the physics that I want you to take away from it is that I teach my physics sport class, the normal force is what's going to push him up minus mg. This is what you're after. You're after the normal force. Because basically when you jump, you push on the ground, and for every action there's what? Say it again. Yeah. There's a reaction in the opposite direction but with the same magnitude. Now you've pushed on the ground with a really strong force. Is the Earth going to get knocked out of orbit because you jumped? Hell no. It's going to push you up. It's going to say, see ya. So basically, you're going m times 4g is equal to the normal force minus mg. Well, I wonder what that's going to do. All right, good job. I mean, I don't mean to tell you like the answers, but at the same time, I think I want to give you some, just get you started, okay? Because I'm getting some pretty pointed feedback on Expert TA so far, and I don't think it's Expert TA's problem, and I don't think it's the student's problem. I think there's somebody at the front of the classroom who's made this a hell of a lot harder than it's supposed to be, especially after today. So anyway, let's take a view of this guy. All right, superhero and trusty sidekick are hanging motionless from a rope. Okay, find the tension in the above rope above superhero Newton's, and find the tension in the rope between trusty sidekick and the okay. You got that? Okay. All right. So the tension is going to be different. That might be, you might be going, what the heck? What the heck is going on here? Well, let's look at problem 2. Let me draw the things, and then I'll clue you in on what's going on. This is just like a train problem. Here's the problem. This is just like a train problem. So that tension is going to be a little bit different. Okay. So in other words, what they're saying is that you got superhero on this rope, and he's right here, and his trusty sidekick is down here, and he's not quite as massive. Okay. All right. Now, you've got M1G going down this way. You got M2G going down this way from this guy. All right. You've got a tension going up here. And you got tension 2 here. This is T1. All right. Because this person is pulling on the rope here, it's being pulled back with equal going up like that. All right. So when we try to find T1, we look at both masses. When we try and find T1, we look at both masses. All right. So with T1, we go, oh, okay. Well, that's not going to be too hard. Sum of the forces in the y direction are equal to, they didn't say they were climbing the rope, are equal to 0, because they're not climbing. They didn't say they're, and if they were climbing, if they're going at a constant velocity, they wouldn't have an acceleration anyway. So what are my forces? Well, I got T1 going up, minus M1G, minus M2G. You look at the entire thing pulling down on it. So now that I put those parentheses around, I got to change that to a plus sign. So T1 is equal to M1 plus M2G times G. All right. Now, pick one of the masses. Pick a mass to solve for T2. I'd pick mass 2. I'd pick trusty sidekick. For T2, pick trusty sidekick. Draw and just cut him out like that. Draw the forces, and you'll find T2. Okay? All right, I'm going to stop here because I don't want to have this be like 50